Today I am going to be walking you through some code concepts. The broader concepts that we're going to be talking about are covered in the PowerPoint Intro to Coding in the Arts, Coding in p5.js, Part 2. And so we are going to talk about three sort of major things. We're going to be talking about what a variable is. We're going to be talking about math. This is four major things: variables, math, conditional statements, and also iteration. So stay tuned for those items. I'm not 100% sure if I'm going to be able to get through all of this in the sort of 50-minute format. So if I am not able to do that, I'll break it up into a second video. So we'll have to see how far we get. So as per usual, I'm not going to kind of stay, kind of strictly to the PowerPoint. I'm just going to be covering the main concepts through coding. So you would definitely want to check back with this PowerPoint and read through it. It contains more information than I'm able to deliver, within a kind of 50-minute demo. So this is basically the background information to what we're going to be doing in the demo. So with that being said, let's go ahead and get started in the p5.js editor. All right, let's get started with the idea or concept of a variable. So what is a variable? Well, if you remember algebra class, maybe in high school or middle school, you probably know what a variable is. So mathematically, a variable is a letter that symbolically holds a number. And it's pretty similar to the way that it works with computers, although when we're addressing variables in computers, there are many different kinds. Luckily for us, JavaScript doesn't actually care what kind of a variable your variable is. So the way that JavaScript deals with variables from the programmer's perspective is actually very simplified. So what is a variable on a fundamental level? It is a container for data. So in this case, I have my coffee cup, and we could call the coffee cup the kind of variable, and the coffee inside of it is the actual data. And it can contain, different levels of data and also different types of data if we're programming in JavaScript. So this contains coffee right now, but I could also use it for tea. I could also certainly use it for orange juice, although that would be kind of gross. So let's put that into practice. If we come into the P5 editor, we can come over here, and we're actually going to just make a new sketch. It asks me if I want to leave this page. You have unsafe changes. Yeah, I do. So, okay, so it created a new sketch for me. That's awesome. I remember last class we were sort of thinking, or last video rather, we were sort of thinking about this idea of the ellipse. I'm going to stick with that. You could substitute really, any other shape. There are actually many other shapes in that 2D primitives section. So take a look at that. You might find some interesting things. But I think we were starting it at 100, 100, 100, 100. And because I'm superstitious, I like to have a semicolon there. Technically, the correct way to do it is to have a semicolon. So I will say that the P5 editor it has this way of not caring about semicolons until it does. So if you're having problems with one of your sketches, the first thing I'm going to do is add semicolons to it if I'm troubleshooting one of your sketches. So let's go ahead and just get that up there and see what it looks like. Okay, so we know that this ellipse is roughly drawn at x, y, And then, of course, we also have the width and the height parameter after that. So what would happen if we made a variable? Well, we could certainly do that. There are multiple ways to kind of set up or declare variables. I'm going to do what's called making a global variable, which is a way of making the variable kind of accessible to the entire code base that you're developing. You can also, I'll go ahead and just do this. So if we want to declare a variable, I'm going to call var. I'm going to also give the variable a name. I'm going to choose something really radical like x. And I can even assign x a value. In other words, I can make x equal to something. In this case, I think we're going for a number because I would ultimately like to use x in here. So let's go ahead and check and see what happens. If we type x in for this ellipse, also, if I'm kind of playing around with variables, it's always really good to know what a variable contains. So one way of doing that is by using the print function. So we can print the value of x, and by doing that, it will just print the value of x to the console. Okay, so that's pretty kind of, amazing. Interesting, perhaps. What can we do to make it more interesting? We're assigning it, we're declaring it and assigning it a value at the same time. So this is actually a shortcut, and in the PowerPoint you'll see this is actually equivalent to this. And that. So this is sort of the long way of doing it, and this is the short way of doing both at once. There's also another way of declaring a variable. I don't want to kind of overwhelm you, but you might see it in other code that is basically like this. And there is actually some small difference there, but you will not notice that difference in the sort of coding adventures that we will have. So in any case, we declaring a variable is basically just like, literally like, I declare that this exists. And so when you declare it, it indeed exists. That's the most Southern I will ever be, by the way, for you. But you could certainly take this variable declaration and have it within the draw function. That works just fine. I'm going to go ahead and comment this out. So if it's in the draw function, it's going to behave exactly the same. I'm going to turn auto refresh on for a little while. So this is exactly the same, right? Now, check out what happens if I take the print function that references x and I move it into the setup function. Oh, big fat error, sketch doesn't run. Why? Why is a good question indeed. The reason that this does not work is because when you declare a variable inside of a function or inside curly braces, it's not, the data and the variable is not accessible outside of that function. So for a lot of things that doesn't actually matter, but for some things it matters a lot. So to eliminate this sort of problem, my recommendation is that most of your variables are declared what would be called globally. When we declare it inside the function, it's known as what is a local variable. So as I said, if you want to kind of like, avoid that problem, by declaring them at the top of the sketch ahead of any functions, you are going to have a situation where the print function actually still works now, because x is accessible to the setup function, and it's also accessible to the draw function. So that's kind of like maybe a little boring. So I'm going to move the print function back into the draw function so that I can get feedback with every single frame or every loop through the draw function. And right now it's not doing anything, it's just feeding 0 back to me. Excuse me. So I could actually change the value of x. Crazy. Let's do it. I could say down here something like x equals, I don't know, 100. Let's try that. Well, yep, indeed, x equals 100. Okay, we can put any number we want in there. We can say, how about x equals fish? That actually works, but fish is not a great value for something that we're going to use for coordinates. So this is where I would say that when you make a variable, it is somewhat important that you know what kind of data you want to store in that variable. Meaning that because this is a variable that we're using for location, and location is controlled by numbers in P5, it's probable that we want to stick to numbers, either, you know, floating point numbers like decimal point numbers or whole numbers. We can put any kind of data that we want in any variable in P5 JavaScript. The only problem is that when you try to use that data, if it's not the right kind of data, in other words, if it's fish instead of 100, that is definitely going to cause you some problems. So, whoops, excuse me. So I would just kind of be conscious of that. Let's think about some other ways that we could use this variable. So we have sort of moving on to kind of like the next thing down the list. We have this ability to do math in p5.js. And math, as we all know, is, you know, maybe exciting, maybe not to some people, but if we want to change the value of numbers, in this case, you know, numbers are kind of controlling what we're doing, we would definitely want to use some simple math or simple arithmetic. So let's try using one of the arithmetic operators that's listed in the PowerPoint. And let's try using the equals operator first, and then use the plus operator. So what I'm asking to have happen here is that x equals x plus 1. So every time this iterates through the draw function, it is going to add 1 to the value of x. Now you can see as it continues, it just keeps adding and adding and adding, because we haven't told it not to do that at any point. We'll get into using maybe conditionals in a little bit. So I just want to let you know that is kind of the foundation of how you would start to think about motion. Motion is really just a number that increases or decreases over time and is used to control the object's location. So in this case, if I play it again, adding 1 to x every single time is going to make it appear to move horizontally. Now, we can also make a second variable if we wish, maybe called y. That's shockingly original. And let's go ahead and see what happens if we use y in a similar way. You can see now that we're actually working in it, our sketch is kind of refreshing fairly frequently. So somebody might ask, okay, well, I've got my variable declared. I've got, 1 added to y. How come my sketch is not reflecting that? Or how come what I see on the screen is not reflecting that the y coordinate is changing? What's going on? What am I doing wrong? Aha, very common question. So what you're doing wrong is you're not actually using the value of y to control the y coordinate of the ellipse, which is sort of the link up that you need in order to make it work. So when we start with x and y at the same time, we get what appears to be a diagonal movement. Super fun. Now let's try one more thing. I'm going to excuse me, just go ahead and save this, and before I change it around too much. So now that this is kind of captured, I'm going to think about other values that I could substitute in for x or y. I'll tell you one value that's kind of useful, and that is the mouse x and mouse y. Those are what are called system variables. So if I were to, in the print function, go ahead and print, sorry, my parentheses are getting out of control here. If I were to go ahead and print the value of mouse x, let's go ahead and let that happen. So our thing is going to just slide off the page, our ellipse. Now, right now it says mouse x equals 0. Well, yeah, that's true, because my mouse is not even on, whoa, there it goes. It's not even on the window. And then when I move it onto the window, you can see I'm getting feedback in the console of the coordinate value of my mouse. So we can use the value or the number that is being stored in mouse x as a way to actually control the ellipse. And guess what? We can do the same thing for mouse y. Whoa! Interesting. So now I'm kind of jumping around code-wise. Like, I just made 2 variables, and now they're not being used. I'm talking about x and y. And that's fine. It doesn't really matter. If you have like a ton of variables that are not being used, that's not really technically a good thing. It's kind of inefficient. So it's also, I think, when I'm working on things, if things aren't being used, I like to comment them out. Mostly, not necessarily for efficiency's sake, but as a way of kind of controlling, my own knowledge of what code is actually doing something and what code is just kind of vestigial. So that is definitely something to think about. So now we have this mouse x, mouse y thing. We can certainly use the mouse x, mouse y in a kind of interesting way. We can use it obviously to, just pull our coordinates of where our mouse is and draw at those coordinates. We can also turn the background off and basically not have a background. And then we can sort of retain the memory of what has happened to our to our sketch. Over time we can actually use it as kind of a drawing app or a drawing capture. So that can be a really useful and kind of interesting approach. I will say, you may be asking, well, what if I want a background, but I want to retain, the movement of the shape? Well, you can do that. The answer to that question would be to use the background in the setup. Because what's happening in the draw loop is the background is drawing over the entire screen every single frame. And so here, the background draws once, and then you are drawing the rest of the screen. So that can be kind of fun too. If we want to maybe make this a little bit more sophisticated, we could certainly do that. We could kind of, let's play around with scale. Let's use a variable, for example. So I'm going to take these two variables and kind of resuscitate them. Let's try something like W and H, and let's play around with the width and the height of this object. So right now we have pretty much, you know, this thing is drawing at mouse Y, and it's 100, 100 width and height. Well, what would happen if somewhere in the draw function we made W equal to a random value between some low number and some high number. So I'm thinking maybe 100 would be the high number, but it's kind of a little chunky looking. So I think maybe 50 and maybe 5 is the low number. So 550. And let's go ahead and see what happens. Absolutely nothing. And why is that? It's because we're not actually using the data in this variable ever. So it's because I'm just being kind of silly, and I forgot to change this to W. So now it should be kind of working, and you can see that the value is definitely changing, but we're also kind of dealing with this issue of the height. So we could certainly just go in here and apply the sort of same logic for now to the height. And then we get something a little more interesting looking. And so, you know, you can start to kind of like do some really fun and interesting things. We could also maybe think about randomizing the color or the opacity. So let's go ahead and make use the fill function. Because right now we're just in sort of default white land. And let's go ahead and stick with default white for now. And I'm going to make white specified in RGB colors for reasons that I don't really, you know, doesn't matter. And what I want to do is I want to set up a transparency channel. So this fourth number, as we kind of noticed in the reference, is an alpha. So this is RGB alpha. So I'm trying to just sort of like think on the fly a little bit here. We've got this number that's between 5 and 50. So we could start and just see what that range of numbers looks like. So let's go ahead and just try that and see how it looks. It's very transparent. So I think I would like to have more variation. So I would like the range of that H number to be closer to from 0 to, you know, the full range of the color spectrum. So from 0 to 255. So I'm actually going to make a little var. Excuse me, I'm always capitalizing things. Why am I doing that? So I'm going to make a var. I'm going to set it to 0 initially. That's just kind of a habit of mine. It's also, I think, a good practice. And the reason I set it to 0 initially is because a lot of times you don't sort of like know what you want, or you can't, you know, set certain values until the setup function has run. So, so here, I can kind of basically just use this same random function that I'm using here. And let's see, I'm going to change this to A. And as I said, I wanted it closer to 0 to 255. So let's go ahead and make that happen. Well, it's still the same, and the reason, once again, is that here in the fill, I'm not actually using the a variable. So here I'm actually using it, and you can see it's kind of splattering a little bit more of an interesting combination between opaque and transparent. Now, we could really kind of like have some fun, and we could potentially make one of these color channels, into a random variable, which would be kind of nice. If we turn all three of them into A, they're actually going to wind up being gray because it's an additive color system. So we don't want to do that, or we could do it anyway, I guess. Why not? There we go. So basically now we're just getting kind of a gray, and we're getting an alpha channel as well. So, and if I wanted to make this kind of, a little slicker looking, I would probably use the no stroke attribute. So there's that. So we're going to take a pause, and I'm going to come back, and we're going to start to think about motion again, and we're going to think about conditionals. All right, so we are going to talk about conditionals next, and let me store myself up here. So all of the code that we've done up to this point functions in that kind of top-down way that we talked about in the last video, where the code will basically draw to the screen in the order in which it's called by the browser interpreter. So there are lots of conditions or lots of circumstances where you would want code to flow in a different way. And so in software engineering, or in your sort of like basic computer science class, they would actually call that program flow. But the way of changing the way that flow works, one of the most sort of popular ways is to create an if statement. So that's what we're going to be doing in just a couple seconds here. We're going to use for our sort of examples, we're going to use potentially some system variables. So we may, I think actually I'm going to start with mouse X, which is not on this list, but is also a system variable that we're using right now. And we'll kind of move on from there. So I did want to show you a couple of things here. There are different operators that apply within a conditional. So if we look back at this sort of pseudocode that I drew here, it says if meat equals true, then pudding equals true. So there's two different things going on here. Within the if statement, if meat equals true is a test. It's testing, and within this these parentheses, it's saying, is meat true? Assuming that meat is a certain type of variable that can be either true or false. That's called a Boolean variable. You could also ask, is x equal to 0? That would be a way of asking, is x 0? This pudding equals true is called the assignment operator, which was covered back when we talked about variables. So here you're actually assigning the true value to the variable called pudding. And then if meat is not true, then you're assigning the false variable. So literally meaning that, you know this thing. Maybe. It's from a very, very old band. Okay, so we are going to jump in, but I did want to point out that these values called relational expressions are fundamentally different from operators like the mathematical operators or the assignment operator, which is the single equals sign. In this case, there's just a table, and there's tables of other things too that, we would certainly want to check out. Excuse me, my goodness. So I think what I'm going to do with this sketch in particular is I'm going to start to use an if statement. And I think what I'm going to do is I'm going to take the sketch that we already have. I'm just going to clean it up a tiny bit. So I'm going to get rid of all the stuff that I'm not using, except for this background function, because I might need that later. So probably the first thing that we could do is come up with a way, let's come up with a simple way of using an if statement that changes the color of the ellipse. So right now we're assigning the color here. That needs a... I'm going to go ahead and save this quickly so I can capture it. Oh, well, I just overwrote the other one. That's great. So we've got the ellipse, which is drawing at mouse X, mouse Y. So to change the color, what we really would need to do is we need to kind of change this, either change the color values themselves or change the fill to change the way that the color applies to this shape. So right now I'm just adding some white space so that I can get some room around this thing to kind of build this if statement. So I'm going to first start by making an if statement with parentheses. And we're missing something really key in here. And what we're missing right now is what's known as the test. So in other words, if this thing is true, then do what's inside the curly braces. And in this case, inside the curly braces is, filling this shape. So right now, because we have no test, it never gets here. So, one way that I really like to test if statements is by using the print function. So I would put the print in here, and I'll just pass a value of like So that's just like a little way of kind of asking the computer, did you get this far? And of course the answer is no, it didn't, because we don't have a test here. So what does a test look like? Well, how about let's just use mouse X as our sort of test variable. Mouse X, we have a pretty good idea of what mouse X should be. Right now it's 0, right? Because we're not anywhere, now it's over here. So it's at 118, we're getting feedback of what mouse X is. So we're only halfway there, so we have to still test it against something else. So what I would say, let's, instead of saying, is it equal to something? Let's say that it's maybe, is it greater than halfway across the screen? So that's 200. And now you can see when it's on the other side of the screen, it is giving us a different kind of experience. And this is actually kind of a neat case, because what it's doing is we're calculating a random value for A every frame. So that's why it doesn't always go back to white. If we wanted to make it always go back to white, we can do that. We can just specify it in what's called an else clause. And so one thing that I'm going to do really quickly, you can see I have a curly brace here and a curly brace here. And by the way, this is all inside of my draw function, so there's more curly braces, right? You have to make sure that those nesting things happen properly. But I am going to go ahead and use a sort of automatic function to kind of get some of this indenting right. So if you go up to edit, you can say tidy code, or you can just do shift tab, and it will kind of make everything nice and tidy for you. One of the benefits to tidying code is that you can see, because this one is the furthest to the left, that one is your outer bracket, and then it goes inside from there. So when you start to have more complex code, that idea of tidying it actually can be really quite helpful, and I do it constantly. So as I said, if we wanted this to kind of go to a place where it reverts back to the same color, if the condition is not true, yeah, we can do that. We just have to add in an else statement. So else, and in this case, our statement is going to be, we're asking it to kind of turn white, correct? So I would say 255, 255. Okay, so here we have white with some alpha transparency, and then it goes colored. So in a nutshell, this is sort of what an if statement is. This is a basic if-else statement now. You could potentially insert, just for sort of sake of argument, you could insert maybe a condition into the else statement, making it an else-if statement. Or you could just have an entirely new if statement. I'm just cutting and pasting this so I don't have to type it, because we are all nothing if not slightly lazy. And so I'm going to kind of go for something completely different now in this sort of separate if statement. Let's say maybe something like if mouse x equals 0, then let's go ahead and make that black. So it's going to stay black until we move it off of that corner. So it's just a way of kind of illustrating to y'all that you can certainly add a different set of conditions to, you can have multiple if statements. I've seen code with, way too many if statements. Okay, so we are going to try something a little bit different right now, and we're going to try something called a for loop. And so if you're looking for sort of where the reference is on the for loop, we can look no further than this sort of idea of an ellipse being repeated. And this should look, pretty familiar, because it's extremely similar to what we've been working on. So we're going to start here in a new sketch. So I'm going to go ahead and I'm going to open up a new window so I don't have to get lost. And I'm just going to draw these ellipses as advertised. Wow, that's earth-shattering. That's some excitement right there. So you can see what's happening. We have many ellipses. They're being offered up at a certain size, which looks like 50 width, 50 height. They're using the y coordinate, which is, it looks like it's increasing by 10 every single time that we draw an ellipse. And then we also, just have a static x coordinate. Okay. So, yeah, we can certainly do some interesting things with this, but may I just say that now that we are going to know better in about 5 minutes, that this is the most kind of like inefficient way that you could possibly code something. Now, that's not to say that it's necessarily wrong, especially if you're making visual art. But if you can find a way of doing what in computer language people call parameterizing, in other words, coming up with a way of describing, the changes in these 4 parameters, you may not have to do them all individually. So that's kind of what we're going for, or that's what we're trying to do when we use iteration. So in the PowerPoint, you can see that these 10 lines of code could also be represented in this way. And I'm just going to ruin the surprise and tell you they're exactly the same. And so we're going to go ahead and spend some time looking at this idea of a for loop or iteration. Personally, I think that the concept of the for loop, or in some computer languages, it's called the while loop, is probably the most powerful and necessary tool in your toolkit. And we're sort of illustrating an example here that has about 10 entries, but what are computers fundamentally really good at? Well, that's a tough question. I mean, maybe, cat memes and stuff like that. But no, I'm thinking about, on a more sort of like technological level, they're really good at repeating things, and repeating things with some level of variation introduced. So when you're repeating something 10 times and you can get it down to, 2 lines of code, that's a savings. But what if you had 10,000 lines? And if you hypothetically are thinking about working with a data source, like data maybe harvested from Google, or medical data, or financial data, or weather data, anything where you have kind of a large amount of information, a tool like a for loop becomes just like the only way you can do it. Because it would just be insane to even think about itemizing those things individually. So let's go over the for loop and how it works. Dun, dun, dun. Okay, well, I'm going to go ahead and pull this out for a second so we just don't think about it. What is going on here? Well, if we were to sort of like think through this, so we've got these ellipses that are drawing, and they're changing by 10. They're actually just changing the y-coordinate by 10 every time you draw an ellipse. You're adding 10 to the y-coordinate. So the way the for loop works is it has 3 parts here. So, and this is covered at length in the PowerPoint. I'm going to kind of put it up here. So you're looking at a declaration, an evaluation, and then an increment. If we're trying to be a little more maybe succinct, we can call this a test. So what is happening, first of all, is we are using what some people call an index variable. So I, in this case, is a tiny little local variable that pretty much only exists within this for loop. But that's okay. I mean, for this one thing, this is definitely a case where a local variable makes sense, because what you're using I for is to kind of control what's called the index, or the number of something that you're addressing. And we'll talk about that more. So in this case, I equals 0. And then you get what's called the test, which is, in this case is I is less than or equal to 100. And then the increment is I plus equals 10. So, well, we can look at this sort of code back here and we can say, okay, well, I, in this case, it looks like corresponds to this increasing number, right? So it starts at 0, and then it starts at 0, it gets tested. Is it less than or equal to 100? Yes. So that's good. It can advance into the next step, which is the increment. And so then I plus equals, and that's a sort of shortcut method of doing what we did with the x coordinate, x. So saying I plus equals 10 is the same as I equals I plus 10. So, and again, those operators are listed in the PowerPoint. So, so yeah, you add 10 to it, and then you wind up with 10. Okay, so after the first declaration, this is basically dead. It doesn't get used over and over again. It only gets used once at the start of the loop. That's the start of the for loop. If the for loop was called multiple times, it'll do it. But as the way that this is written, this will only get called once per run of the draw loop. So when the draw loop resets, it will get called again. Okay, so, but we're trying to get through the for loop right now. So we're at 10, and it's still testing. Is it less than 100? Yep, definitely add 10. So it's going to keep buffering kind of through these two things, the test and the increment, until the test fails. So once this reaches 110, we are not going to add any more data to it. Or in this case 100, because it's less than or equal to. Okay, so now how do we use that? Well, in this case, we're just sort of using it for the y coordinate, and we're using it pretty much in the same way that we're using it in the long form code. So you can see here, yeah, we're using I, and if I wanted to just kind of like push the point here, we could ask ourselves, and this is certainly kind of a good thing to do when you're in a for loop, especially if you're just learning how to use for loops. We could certainly ask the p5.js thing to print out the value of I. And that would be kind of interesting. So it is going to every single frame. This is about what we would have expected. Every single frame, it starts at 0 and it iterates by 10 up to 100. So let's kind of play around with some of these parameters just to sort of, drive the point home. What happens if we start I at 100? That's pretty uneventful. All you get is I equals 100 because it basically declares itself, does not pass the test. So the value here is 100, and you can see the value is 100 because that's what we told it to do. What if we start at 10? Well, then as promised, we have kind of one fewer circles here. So I personally am kind of a start at 0 kind of gal, just because it makes things a lot less confusing. So I would recommend that 0 is just kind of a good, nice, logical place to start. We could certainly change the test. What would happen if we tested it so that it were always true? I'm not going to do it, but I'm just saying what would happen. What would happen if this test were always true? You would be probably force quitting your browser, and it would be just, kind of like running forever. So that is, I guess, the potential danger of a for or a while loop, is that they can be written such that they run forever, or kind of like infinitely fill up your hard drive, or something like that. So I guess, if you're looking for any kind of sort of disaster aversion advice during this video, I would say just make sure that this test is something that will someday be true. So don't make it something like I is greater than or equal to 0. Because that is always going to be true. Therefore, your for loop will continue ad nauseum. So that's not so good. I'm not going to do it because I want to actually continue making this video. So the increment is also kind of super fun. So a really common increment is 1. In fact, that's probably the most common increment. It's so common that there's even a special operator for it, and that operator is the double plus sign. So there it is. And in all of its excitement. So it looks like it just refreshed. I'm going to go back to the sort of plus equals 10, just because I think visually it's a little nicer. By the way, if we do plus equals 1, that is, equivalent to the plus plus, right? So, great. Yes, excellent. Okay, so I think at this point I would maybe say that we could kind of fork this sketch. In other words, copy it and make a variation. And we could then try some new things. So that idea of, sort of like starting and making copies of your variations is just as important, potentially more important in code than even in some of the other things that we've looked at. So the first thing I'm going to do to like make something fun here out of our little for loop test is I'm going to delete these ellipses that are drawn in this sort of not so efficient way. And I think I can pretty much leave that where it is. I'm going to make the screen a tiny bit larger. And I'm just going to try a couple of things really quickly because I want to respect your time. And by the way, there are tons of examples using conditionals and for loops on the course website. So the first thing I'm going to do is right now I'm kind of drawing this at 200, 100, or I'm starting there. I'm going to start the drawing at 0, 0. And I'm going to do something that I have not shown y'all yet, and that is I'm going to use a function called the translate function, which is super fun, but you can get into a little bit of trouble if you let yourself. And I'm going to translate to 2 system variables. So it just so happens that this 500, 500 are stored in 2 system variables called width and height. How useful is that? So I'm going to go for width, width divided by 2, and height divided by 2. And you can see what has effectively happened is that my drawing has translated itself to the center of the screen. So now when I draw at 0, 0, I'm actually drawing here. So translate can be awesome if you want to work in kind of a concentric or a more sort of like radial composition pattern. And then now the next thing I want to do, let's see if I can maybe throw in some of these random functions. So I'm going to kind of do what I do all the time, which is I'm grabbing code from one thing to kind of add it to another thing. So I'm adding my little variable declaration, and the important part here is that I take it and put it at the top, which is where it went in the other sketch. And then I also have to take everything that's kind of associated with that variable up to the point where I actually kind of implement it or put it into the code. So I'm going to grab that one line, and that is going to go, we're sort of getting into a little bit of program flow type stuff here, which is actually really important to kind of think about. So let me go ahead and just add this W here, and stuff is going to start happening. Now, you may notice, yes, indeed, things are happening. Now, this W is assigned the value that is generated by the random function here. So it's a value between 5 and 50. And you can see that in our ellipses inside our for loop, we are getting 10 instantiations or 10 instances of this same sort of random value. So the reason is because it's calculating one random value and then it's executing the whole for loop. So if we wanted to have a different value for every item in the for loop, we would need to insert our sort of value assignment here. Actually, we have to insert that into the for loop. And you can see now that they are all indeed sort of unique. Okay, so that's fun. Now let's go ahead and do just a couple of quick things. I am going to take the for loop, this one, and I'm going to make it a little bit longer. So I think I'm going to take it down to like maybe 200. So it's basically just going to give me more shapes. I could even take it like down to 300 if I wanted to make it even longer. Great, cool. And let's see. Now, I'm going to do something that could potentially bug people, but you know, I think it'll be fun. Let's go ahead and take this for loop, which is basically this kind of loopy thing, and let's kind of take this to the next level. So I'm like, whoa, what did I just say? So in other words, let's make a for loop for the for loop. Ho, 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 ho. Yes, indeed. So there are a couple of other examples on the course website of a kind of multi-nested for loops. Now, I'm going to go ahead and do something that is very wrong, just to kind of illustrate why it's wrong. Let's see, and then okay, so and then I'm going to put some curly braces in here. So I want to make sure, the only thing that I have to kind of check to make sure here is that my curly braces, if I open the curly braces here, that they close. Sorry, that was my fault. And this is where this kind of like auto closing thing can be kind of annoying. But basically, okay, so what is happening? Well, we have two for loops, and it looks like there's one for loop that has kind of wrapped itself around the inner for loop. Okay, so I gave it a different value for the test. I'll explain that in a second. And then we're probably going to also have to change this value. What is wrong with this picture right now? Well, I'll tell you. What's wrong with this picture is that we're using the variable I in this for loop. And then inside the for loop, we're redeclaring I and doing some more stuff to it. And so that is kind of considered not okay. Not good. No good will come of it. So I would basically just use a different letter for this for loop. So I'm going to use J, which is a common complement to I. You can see right now this is moving like at a snail's pace, and it's because I'm asking it to do like tons of stuff. And so I'm just going to disable the auto refreshing for just 1 second. And now, okay, let's kind of think through this. For j equals 0, j is less than 2 pi. So 2 pi is about, 6.8. Yeah. That's how rotation is handled in p5.js. And then we're going to add to j every 10 numerical units. So I think what should probably happen here is that j, or rather, so one thing that I'm going to check before I kind of activate this, I'm going to go ahead and comment out the inner for loop, and I'm going to test the value of j. This is a really kind of like prudent thing that you can do to just kind of check yourself and just make sure that you're not going to do something kind of, dumb. Okay, so now the problem here is this. For j equals 0, j is less than 2 pi. Again, that's 6.8. j plus equals 10. So what is happening basically is that this loop is not going to go anywhere. So we could certainly just lower this to 1 and see kind of how far we get. And so as, kind of expected, we get to about 6. So that seems reasonable. It seems reasonable as a place to start, or to start kind of like thinking about it. And what I mean by reasonable is it seems like a not crazy number of, things to have on the screen. So let's go ahead and bring back our inner for loop, and we'll just kind of get back at the ranch here. Now, this is kind of barking at me because it uncommented this little comment. That was just my mistake. Okay, so there we have this thing now, and it looks like all 6 of these are just on top of each other, and that's okay, I guess. There's not really anything wrong with that. So I'm going to go ahead and bring in the rotate function and see what that does. Haha! Well, it appears now that we have some sort of spread across the, 360 degrees. So again, 360 degrees is 2 pi. So by iterating by 1, we're not actually providing like a sort of good value, for it to to work off of. So I think I'm going to try for a slightly different value here. And I think I'm going to go for something like 2 pi divided by, could really be any number. I guess maybe like 12. Why not? Let's see what that looks like. So let me see for just one quick second. So it looks like we've got a couple that are kind of stacking on each other on this sort of perpendicular axes. So that's because of this iteration value. So I'm going to just think about that for a second. I'm going to comment out this print function because what I really am interested in this case is the value of j. So yeah, it looks like it's generating, you know, a number between 1 and 6 for sure. Let's see, 1, but it looks like they're really, some of them are really close to each other. So probably what might be interesting here so I just reduced it to 4, and I'm going to do one. You can kind of basically like play with this until you get it just perfect, you know, and it's just basically like figuring out the math. I'm going to do one more thing to kind of make this a little bit more interesting and active. So I'm going to make another variable, and I'm going to call this variable, I'll use this alternative syntax. I'll call it rot, short for rotation. And I'll say, oh, it's really loving that right now. Let rotation equal something like 0.005. And then what I'm going to go ahead and do is I'm going to add a rotation to this rotation value. So I'm going to add rot in there, and I'm in caps lock. Okay, so there's rot, and now somewhere in the draw loop, I'm actually going to take rot and increase it. So similarly to the way that we increased the sort of number of coordinates when we made something move, we just made one number kind of go up or go down, right? We can do that with rotation values as well. So, and that will make things appear to spin. So we could certainly do that. So I'm going to do it right after this background declaration. And I'm going to use the plus equals function, or operator rather. So I'm going to go ahead and just give it some kind of a small value to start off with. And as you can see, small values can kind of make a big difference, especially when it comes to rotation. What's occurring to me actually about this this rotation matrix now, I can kind of see it, is that I think what we need to do is actually, I'm putting it back up to quite a few. I think what we need to do here is declare something that's called a push. And then I think at the end of the for loop, we need to basically declare what's called a pop. And that pretty much kind of solved our problem and evened out our problem. So that's actually like I would say moderately, like it's intermediate level kind of mojo. Push and pop is really just a way of kind of resetting what is called the transformation matrix. And so you can definitely find videos on how to use push and pop. I'm not going to go into it at length, but particularly if you're using a lot of rotation, that is a situation where you would probably need to use push and pop a lot. If you're doing movement or, kind of randomness, you probably don't need to use push and pop at all. So I know we've done a lot today. We're going to kind of look forward to what's going on, next week. I'm going to be talking to you about how to make things more interactive. We might also think about integrating some sound. Who knows? Maybe I'll bring my cat out and, have it meow at the computer. No, not really. But maybe I should. Anyway, have a great week, and don't hesitate to reach out to me, if you want to talk about your sketches or you're having an issue. Okay, bye.